I am the Philosophical Bachelor, and today I want to talk about physics versus metaphysics. Does science have all the answers? Is it simply a matter of time before science can answer all our most pressing questions about the nature of reality? Can physics suffice to explain everything without a metaphysics? Recall with me how we were being taught physics in school. We were taught laws which were then used to explain certain phenomena. For instance, Hooke's law, where the extension of a spring is proportional to the force applied to the end of the spring, or Lenz's law about how light travels faster or slower in different materials. Or Newton's law of motion and gravitation, or the laws of conservation of mass, momentum, energy, and for more advanced students, conservation of mass energy and Einstein's laws of relativity. These are all rather neat, reducing complex phenomena to equations which we can then use to calculate outcomes, and these relations could be useful when building machines or structures. But why does Newton's law of gravitation, for instance, work? I don't recall asking my teacher that. It did not quite occur to me at the time to question the capital L laws of nature. But let us imagine an inquisitive and bright student who did. The teacher may explain that bodies attract each other, but why do they do that? We may understand how the laws of gravitation works, causing planets to orbit elliptically around their sun because of their mutual attraction, but do we understand why such mutual attraction exists? Scientists observe phenomena and then try to separate out and reduce these observed behaviors into laws, usually expressed in words but also mathematically in equations, so that we can make use of them to predict future phenomena and build things. So when a scientist tries to explain things, they often resort to the deductive nomological model already articulated by the ancient Greeks, but first clearly stated by Carl Hampel in 1942, who devised the covering law theory of scientific explanation. The idea is that scientific explanations use logic, where premises lead to conclusions. The premises will have one or several laws, which are why they are called nomological, nomos meaning law in Greek. Further premises may include some particular facts, and together these premises lead to a conclusion. For example, a nomological premise is Newton's laws of motion, with an additional premise of how a ball, which was resting on the floor, is kicked. The conclusion is that the ball moves in a trajectory as described by Newton's laws of motion. Two criticisms have been brought against the deductive nomological model, according to Samir, Okasha, who is author of Philosophy of Science, a very short introduction. They are the problems of symmetry and irrelevance. The problem of symmetry arises because the model cannot distinguish which is the cause and which is the effect. In this model, there is an equivalence in explanation between cause and effect. For instance, using the deductive nomological method, the length of a shadow caused by the length of a flagpole is the same as saying that the length of the flagpole is caused by the length of its shadow. However, that is incorrect since the flagpole length was probably caused by the carpenter who decided to cut it to that length. The problem of irrelevance is that the premises of the arguments may not be relevant even if they lead to the right conclusion, such as a man being unable to get pregnant, not due to his sex, but due to his taking birth control pills. The law here being that those who take birth control pills do not get pregnant. An alternate theory of scientific explanation, causation, does not have either problem. A cause leads to an effect, the paradigmatic example being a billiard ball. The cause, striking another, causing it to move, which is the effect. Causation, however, faces two serious challenges. First is the challenge from David Hume, who argues that cause and effect do not exist. All we have is contiguity in time and place, priority in time, and constant conjunction. When the second billiard ball moves, all we can say empirically is that the movement of the first ball was prior to it, and when they touched, the second ball moved, the touching coinciding with the motion of the second ball. We never directly see causation. The second challenge is closely related to the first. Immanuel Kant tells us that causation is just something in our heads, part of the condition of our understanding which helps us make sense of the world. Causation is a relation we project onto things and are not in the things in themselves. However, even if we accept either or both of these theories of scientific explanation, they both still face a major deficit. We may be able to explain how the law of nature works, or how the cause caused the effect, but we still do not know why. Gravity, as represented by Newton's law of gravitation, occurs because bodies are attracted to one another. But why are bodies attracted to one another? The white billiard ball struck the black one, and the black one is caused by the white one to move. But why? Because the momentum of the white ball is transmitted to the black one. But why? Why is momentum conserved, or for that matter, mass and energy also? A scientist may reply that that is just how nature works, that it is a law of nature. But why is nature like that? Science has a problem answering that. It explains appearances using something that is even less familiar than the appearances themselves, namely laws of nature, writes Arthur Schopenhauer. The collection of effective causes used to explain everything always rests on something completely inexplicable, namely the original qualities of things and the natural forces that emerge in them. Example, gravity, solidity, momentum, and chemical forces. This law of force of nature is now an absolutely inexplicable remainder, but these remainders also require explanation. We may be able to use science to explain how a butterfly flies, but science cannot tell us why it flies. For that, we will need knowledge that is beyond science. Any physical explanation in general, and as such, still needs a metaphysical one that provides the key to all its presuppositions, says Schopenhauer. What are some of these presuppositions of science? We have already talked about laws of nature, which themselves remain unproven, but must be assumed to allow proofs. What permits the law-likeness of nature? A big and fundamental presupposition is how we live in an orderly universe such that we can even find laws that can be expressed mathematically to describe phenomena. Part of what even allows order is persistence, that things continue to exist on their own, and equilibrium, where things when perturbed try to return to a stable state. Is investigating phenomena, the happenings that we can observe, sufficient in establishing reality, or is there an underlying reality that may be different? Even for the logic that we employ, why are the principles of non-contradiction and identity true, and are they universally true? All of these may seem like common sense, but if you really think about it, they are not quite as obvious and self-evident. Questioning why they are so is in the realm of metaphysics. So, what is metaphysics? Schopenhauer explains, "By metaphysics I understand any cognition that claims to go beyond the possibility of experience, which is to say beyond nature or the given appearance of things, in order to disclose something about that which in some sense or another conditions appearance, or in common parlance, about what is hidden behind nature and makes it possible." In case you are wondering what some examples of metaphysics are, you are already familiar with some systems of metaphysics in the form of magic, myths, folktales, and religion. The various religions offer their own metaphysics. For instance, the Abrahamic religions tell us that God created the heavens and the earth, and how after we die, we will one day be awoken for final judgment. Hinduism and Buddhism tell us that after we die, we will get reborn, and the cycle continues indefinitely unless we become enlightened. Non-religious metaphysics, such as those found in philosophy, include atoms first articulated by Democritus, Plato's theory of forms, Aristotle's hylomorphism, Neoplatonic emanation from the One, Gottfried Wilhelm Leibniz's monads, Spinoza's pantheistic monism, George Berkeley's idealism, Descartes' dualism, Schopenhauer's will, Harry Bergson's Elan Vital, and for many other thinkers, the metaphysics of materialism. Humankind has made massive strides in extending our scientific understanding and has managed to successfully apply this knowledge towards creating technologies, which testifies to the usefulness of science. Some, like the logical empiricists in the 1920s and 30s, have thought science would displace metaphysics altogether. After all, the reason why primitive people came up with folk metaphysics in the form of magic myths and folktales was to explain natural phenomena they could not understand, a god of the gaps. With the rise of science, we now can understand many phenomena, hence decreasing the need for stories and magical thinking. However, science does not have all the answers on the nature of reality, and not just because it has not yet reached the state of advancement to give us those answers. Instead, it cannot even in principle give us those answers to the why of why things are and operate as they do. simply because that is not within the domain of science. Science can investigate phenomena and its relation to things and other phenomena, but it cannot tell us why things and their relations are the way they are, for that is the role of metaphysics. Precisely because we have made such advancement, our desire to know what underlies phenomena is even stronger. Schopenhauer elaborates. The greatest advances in physics will only make the need for a metaphysics more palpable, because on the one hand, a corrected, extended and more thorough understanding of nature always subverts and ultimately overturns the metaphysical assumptions held to that point, and on the other hand, it lays out the problem of metaphysics itself more clearly, correctly and completely, separating it more cleanly from everything merely physical. And also because a more perfect and precise cognition of the essence of particular things bring with it a more urgent demand for the explanation of the whole and the universal, which only presents itself as a greater riddle the more accurate, thorough and complete our empirical cognition of it is. By now you may be wondering that there has been a slew of metaphysics, some of which I have named above. But given that they are beyond the methods of science and hence testability, how do we know which one is the right one? Schopenhauer uses two metaphors in response. Imagine we discover a stone tablet which has carved into it a text in an unknown language. We formulate a hypothesis of what each letter could be such that the words and then the entire script make sense, and it would probably only fit one way and not by chance. The second metaphor is a riddle's solution. A solution to a riddle proves itself to be correct by the fact that it fits with all ways of expressing the riddle. In the same way, a correct metaphysical theory will bring to our understanding of the world a harmony that would not be perceived without it. Schopenhauer does not say this here, but the theory also must have a certain simplicity and elegance, such that it does not rely on ad hoc patches to cover the holes in its main thesis. Some of the examples of metaphysical systems I have given above can already be thrown out of the race, such as Platonic forms, because it runs into all sorts of logical contradictions. That we have quite a few metaphysical theories that satisfactorily explain reality remaining possible today simply means that we have not reached a state of sufficient knowledge, be it in the sciences or other fields of inquiry such as philosophy, to definitively throw some more out, though there is potential to do so. For instance, quantum mechanics and its accompanying indeterminism may make the materialist determinist account untenable, while injecting new life into theories arguing for conscious free will. While the discovery of atoms have put paid to metaphysical systems that are dependent on matter being continuous and hence endlessly divisible. Cosmological systems that rely on geocentrism and the perfection of the heavenly bodies, such as Aristotle's and Aquinas', have lost all credibility, despite being the leading theories for millennia. New discoveries may yet breathe new life into theories previously debunked, while some theories may be able to be refined and updated with new discoveries that may strengthen its claim. Others are best left in the dustbin of history. So no, philosophy is not a dead end at all. In fact, there is much work to be done. The title of this essay is Physics versus Metaphysics, but by now you have realized that this is a false dichotomy. Physics and metaphysics intersect and inform each other but are two separate domains of knowledge, both interesting and important. Metaphysics may be more theoretical but informs meaning, while physics has more practical applications and informs use. But without meaning, what is the use of use? I have named but not described any metaphysical system in this essay, but I do explain Spinoza's, Schopenhauer's, Bergson's, Heidegger's and others on the channel compiled in a playlist entitled Metaphysics and linked in the comments. Do you want to know the why that metaphysics may be able to provide? Or are you satisfied with the how that science provides? Do you think our need for metaphysics has increased even as our science has advanced the way Schopenhauer believes? Tell us in the comments below, and thank you for listening to The Philosophical Bachelor.